So hello everybody, my name is James Thomas and I'm a developer advocate for IBM working in our cloud division. I was kind of invited here to talk to you today about using a technology called Docker and using it to kind of move our applications into the cloud. I'm going to kind of spend most of this talk showing you the live demo of how to take a kind of sample application, wrap it with Docker, how to build it so we can deploy it really easily across all of your infrastructure, and then we're going to look at moving that into a big public cloud provider. Now, Docker as a kind of technology is still relatively new, so it was only released for the first time in kind of March 2013, so it's just a sort of 3 years old, 3-year birthday this month. But the popularity of it among developers has kind of exploded. So if you go to GitHub and look at the Docker page, because it's open source, you'll see that Docker has 28,000 stars. It's the 20th most popular project on the whole of GitHub. It has close to 8,000 forks. So before I kind of jump into showing you how to use Docker, I want to kind of step back and think about why has Docker become so popular? Why did it get so popular so quickly? And what is the kind of problem that it's trying to solve? Now, I'm sure as kind of modern software developers, you're all familiar with this idea that there's a tremendous pressure on us to deliver more software, to deliver software faster, to kind of shorten release cycles, right? Gone are the days of waterfall development where you might spend 3 months, 6 months, even 12 months working on a particular release of software. Because the problem with waiting that long between getting your software into the hands of users is obviously you don't get any feedback during that time, right? And that's where Agile development came when we have much kind of shorter sprints, shorter release cycles. We can get our software into the hands of users quicker, get feedback, and go through this kind of iterative product development. So now, rather than companies releasing software, especially on the cloud, right, every 3 months or 6 months, they're releasing, every week, every day, sometimes multiple times a day. And you've got companies like Etsy who kind of very publicly talk about, deploying changes into production on their live site 30 or 40 times every single day, without any kind of visible downtime to users. Now, one of the ways that you can kind of realize this goal of having very short deployment cycles is through tools like, or tool chains of kind of continuous delivery, continuous integration, right? Having completely automated build and deployment pipelines so that when, as a developer, I check some code into my source control, it gets pushed through all my test systems and my staging systems and can go automatically out to the user without any manual intervention, right? And this is awesome for me as a developer, right? I don't now need to raise a ticket with IT and wait 6 weeks for Jeff to copy some WAR files about between virtual machines, right? I can be responsible for getting code into the hands of users. But if you do this and you set up these kind of completely automated deployment pipelines, what you'll find is your code still moves through a tremendous amount of different environments, right? So it will start off in development, where I'm doing my kind of local code and unit testing and making sure that everything is working. Once I've checked it in, it'll move through a number of different test servers, right? So unit tests, integration tests, system tests. We're going to move through all of these environments, making sure our code is working. And we'll probably go to some kind of staging environment. So, some kind of pre-production system where I can check everything's working, do my smoke test. Before finally, we'll go into production, right? We're going to get it into the hands of our users. And today, for many people, production means moving to the cloud, taking advantage of the kind of elastic scalability and the lower costs that cloud can bring today. But I think one of the big challenges for software developers today is keeping all of these environments the same. A common source of kind of issues that creep in is often to do with differences that creep into these environments, right? So it turns out that, kind of development has version XYZ of some system-wide library, and then it ends up in production. You have a slightly different minor version. This can cause your deployments to fail and kind of really slow down the goal of getting software into the hands of users really quickly. And if you do see kind of differences creep into the environment, you'll often hear this dreaded phrase of, oh, it works for me, right? Has anyone ever said this phrase when they're trying to track down a deployment issue, right? I've definitely heard it lots of times. I've probably said it more than I've heard it. And the scenario is obviously, developers check some code in, they broke system tests. You go to track down this idiot developer and say, why are you checking that broken code? Why have you broken the build? And they said, wasn't not my problem, works on my machine. And they're telling the truth, right? It did work for them. It's just that by the time it gets through to another environment, it's not working anymore. We've seen some environmental differences. And this is a problem if you want to be releasing software very, very quickly, right? When you were doing waterfall development, if you every 6 months have to spend a day or half a day getting all of your environment set up to release some code, it wasn't too much of an additional delay on your kind of release cycle. But if you want to be releasing code every day, every hour, I can't be spending hours and hours of time kind of maintaining consistent environments. And this is the problem that Docker tries to solve. It tries to solve the issue of maintaining consistent environments across all of your deployment infrastructure. And Docker does this by providing you with a mechanism to bundle your application binaries and your code and any kind of dependencies and libraries, along with kind of configuration about the environment that the application expects to run in, and bundles this into a kind of what they call a single lightweight binary image that you can move across all of your deployment infrastructure. And when you execute it again as containers, is guaranteed to execute in exactly the same environment. It completely kind of removes the possibility of encountering any of these kind of works on my machine issues. Now, if people haven't heard about Docker and this kind of new technology to them, often I think in their head they'll mentally associate it with like virtual machines, right? It's kind of some kind of lightweight VM technology. But Docker has some fundamental differences between how it works and VM works that gives Docker, I think, a number of really good features. So with a VM image, you're bundling not only your application code and your binaries and the libraries, but the entire virtualized operating system into that virtual machine image, which means that they can get really, really big, really, really fast, right? It's common to have VMs that are tens of gigabytes in size. They always lend themselves to moving around development environments in particularly quickly. And with Docker, we run our application as what's called a Docker container, and it's a completely virtualized process run kind of isolated and safely. But the way Docker does it, it provides a way to share the host operating system in a kind of secure and isolated manner. So now you don't need to bundle in that entire virtualized operating system into your Docker image, which means they're much, much smaller, much lighter weight, and they're easier to run. Docker has lots of other great features, as I said, which has made it so popular so quickly. So it's open source, right? It's free to use. You can go to GitHub and get it running, and all you need is a kind of Linux machine. And it's, as I said, become incredibly popular. So it's got 28,000 stars. It's the 20th most popular project. It's got close to 8,000 forks. But it's not just had a take up across a kind of developer community. Big companies like Google, Microsoft, IBM are all involved in the Docker project now and kind of providing support across the enterprise. It runs on Linux, so that's all you need to kind of get it working. What Docker actually does is leverage some technology in the Linux kernel called LXC, and what Linux containers allow you to do is run this kind of virtualized instance of a Linux operating system in kind of complete isolation from the host, but sharing the kernel, which means the images are much, much smaller. And the original implementation of this technology is almost 10 years old in the Linux kernel, so it's been around for quite a long time. But what Docker did is made it really, really consumable and easy to use for developers, and that's when it blew up and got so popular about 3 years ago. As I said, it's very lightweight, especially compared to VMs, because you're not adding in the whole kind of operating system into the image. It definitely has this, what they call write once, run everywhere mentality. I'm sure you've heard that before. But really all you need is a Linux system with Docker installed, and you can run your images as containers on that system and be guaranteed to execute in exactly the same environment. I think a really nice feature for developers is around versioning, right? So with your source control, when you make changes to your app, you save those into the repository so that if you get into difficulties later on, you can roll back really, really easily to different versions. And Docker allows you to do the same with your application images that you build. It allows you to version them so you can swap between them really easily and roll back if you get into difficulties later on. It's not so easy to do that with a VM. It also has this wicked site called Docker Hub. Docker Hub, but you can think of it like GitHub for Docker images. It's a kind of public repository where you can upload your images that you've created and other people can, and it's easy to pull them down and get started. And it's become really, really popular for the big open source projects, so MySQL, Redis, MongoDB, as a way for you to get their code up and running on your system, right? If you think about what you had to do to get MySQL version, 4.2 running on your laptop, you have to, make sure the runtime was set up and all the libraries it depends on, the version of, all the things that it's going to kind of compile, and then set up all the configuration and then install the binaries and then run them locally, right? You're kind of polluting your development environment with this database. But with Docker, you can pull down the image and you can run it in a kind of isolated context, and then when you're done, you throw it away with it and you don't need to kind of pollute your operating system. Again, one of the things about Docker Hub is that it's completely public, right? So everything you put up there is accessible to everyone. So we're not going to really use that for our internal development. But Docker Hub is just an example of what they call a Docker registry. And a Docker registry is just a repository of Docker images that you can talk to, and the Docker command line knows how to pull and push images to. And you can run one of these internally for your kind of own development purposes. And there are some of the kind of reasons why Docker's got so popular. But what about Docker in the cloud? Because I think actually Docker kind of comes alive when you're talking about cloud, because when you've done the hard work of bundling your application into a Docker image, it actually makes it really easy to move to public cloud, because I can just give the public cloud provider my Docker image and they can run it in production. I don't have to worry about setting up lots of different cloud environments. Right? I don't have to SSH into VMs and kind of configure Linux. I can just give my Docker image to my cloud provider and they can run it for me in a kind of scalable and production way. And kind of lots of the big cloud providers have kind of started to jump on the Docker bandwagon, because it makes it really easy for developers to push their applications up into the cloud. So whether you use Amazon Web Services, Microsoft Azure, Google Cloud Platform, IBM Bluemix, they're all providing you with the ability to push your code as Docker images rather than the kind of raw application binaries. And obviously, to do my demo, right, and then we're going to use the cloud, I need a kind of public cloud provider. And we're going to be using IBM's cloud today, but the kind of techniques and the steps I'm showing you are applicable for any big public cloud provider that we're going to kind of run through. And the great thing about cloud, obviously, is like you don't have to worry about infrastructure, right? You can concentrate on your code, let the provider worry with kind of infrastructure. Now, a question you might have is, well, why would I have some kind of third party to run my application as a Docker container, right? You said that Docker is open source and all I need is Linux, right? Why can't I just kind of do this myself? And you could do that yourself, but I think this is a kind of key decision point when you're thinking about kind of running Docker in production, because there's a huge difference between running a kind of Docker container locally on a laptop and kind of building that and turning that into a scalable production system, right? There's all kinds of things around orchestration, are my containers making the most effective use of my infrastructure at all times? Am I scaling in response to user demand? What about monitoring, performance, logging, all that kind of stuff that's kind of quite difficult but also quite boring. And there are a number of open source projects that have helped, or that have tried to step in and help, especially around the orchestration side. So people might have heard of projects like Swarm, Mesos, Marathon, Kubernetes by Google. But I think it's as I said, it's a key decision point when you're thinking about using Docker in the cloud, is that, do you want to be responsible for running a kind of production system and all those factors I talked around, orchestration, monitoring, or do you want to let the cloud provider do it for you? Because then all you have to do is build your application into an image and everything else is taken care of for you. But when you're using Docker in the cloud, it's not just around the infrastructure and the orchestration side of it. Lots of the big cloud providers try to give you lots of tools and services to make it really, really productive. So for example, things like a private registry. We talked about Docker Hub as this public registry. You can go and get all these great open source projects, but I want my own private one that I can use for development that's kind of secure and authenticated for my company. Docker is as a command line kind of tool, right? Do you want a kind of web-based GUI that can help to make things a bit easier to manage? Cloud-based services, right? I think one of the best things about developing applications in the cloud is using what they call cloud-based application services. So traditionally, if you had a kind of 3-tier web application, you had some kind of MySQL database you were talking to, right? You probably were responsible for standing that up, managing it, and kind of running it in production. But with the cloud, you can just provision a cloud-based database, and the provider has to do all that kind of boring stuff of making it production ready, and you just get the credentials and can be able to talk to it. And that's something you can do using Docker in the cloud. Deployment pipelines, do you want to build your image yourself locally and then push that to the provider? Or do you want to get the provider to hook into your kind of CI pipeline that they can automatically create those images and push them into production without you having to do anything? Machine size, you want the ability to configure how much memory and CPU and RAM that my containers run in production. And also, if we've kind of architected our containers to be kind of stateless microservices, right, I probably want to run multiple of them concurrently and have the platform load balance requests coming in. I want to kind of scale up and scale down based on user demand. So it's what we call container groups in Bluemix, but I'm sure it's called something else. on some of the other providers. Obviously, there's the whole monitoring and kind of operation side of it. And I think a really interesting feature is around vulnerability scanning, right? When you build your Docker image, as we'll see kind of shortly, you often use what they call a base image. So it's an image someone else has already built to set up like the language runtime and any libraries that you need to install. And often, if you're depending on that, you want to be notified whenever there's any vulnerabilities which affect that. It can nudge you to rebuild and kind of update to latest version. And Bluemix and a lot of the other cloud providers will automatically scan your images and kind of help you manage that stuff. So demo time, right? And I'm going to spend most of the rest of this talk now kind of at the command line at the web, kind of showing you how to use Docker in production. Hopefully the Wi-Fi will stay up, but I do have a kind of video backup if everything goes really, really badly wrong. And I'm going to take a sample application, which is this. I'm going to wrap it, I'm going to run it, I'm going to wrap it with Docker, run it locally, and then kind of move it into the cloud. You can go and grab the source code yourself if you're in the audience. It's called Blue Chatter on the IBM Bluemix org. And it's just a very, very simple kind of web-based chat application, right? You can use the web CLI to kind of talk to each other. And architecturally, there's a Node.js kind of front end which handles all the front end stuff, and then we've got Redis in the back end, and we use the pub sub features of Redis to be able to send messages to the kind of different users. And again, the Node.js part of it, front end, is stateless, so we can kind of scale horizontally by adding more instances really easily. So let's think about running locally, right? And let's think about running locally without Docker. Imagine that I am a developer in an organization, and I've just joined and we're working on the Blue Chatter app, and say, right, go and get it set up and get it working. So let me drop out and unmirror my displays. Let's see if this works. And then let me take the res down. Yeah, is that okay? You all see that? Okay, so it looks like it's working. So this is the kind of the Git repo with the code. And again, if you want to follow these instructions later on and kind of go through what I've taught you, the README, the Markdown README has a kind of full instructions of how to do this. So if I wanted to get this code running locally, I would kind of go and clone the code. Or let's just double check the Wi-Fi is working. Okay, so far so good. It's going to break at some point, isn't it? Okay, so I'm going to go and clone my code. Okay, so I've got my project directory, and I can see this is a Node.js application, so I need to run npm install, which is gonna pull down all my Node modules. So if you're not familiar with Node.js, it's just that kind of Node package manager, and all my dependencies that I rely on, it's gonna kind of pull down, and I can hopefully start it up and running. Okay, take a little bit of time. Okay, nearly done. Okay, there we go, right? So there's all my dependencies. That worked, so not too bad. And now, okay, they say, I need to type command npm start to start it. And what happens? Well, it blows up, right? It blows up because, I didn't have my Redis server. So now I need to go and get Redis and put it install and make sure that's up and running. So I already have, I've already got Redis up and running, so I'll start Redis and I can go back. And it looks like this time it has worked, right? So port 6011 says that I can kind of connect to it. And this is what it kind of looks like, right? So I'll just quickly show you on another, I'll put like Henry, and Henry can say, hello, James. And you can see it come through, right? So it's a fairly simple kind of Node.js application. But imagine we were trying to give this to our colleague who's not a kind of Node.js guy, right? He's like, I don't have Node.js installed, I don't have npm installed, I don't have Redis installed. So you need to get all of this stuff on your local development environment before you can even start. And by the way, make sure that you have the exact versions of Node, npm, Redis in your environment, or it's probably not going to work, right? But we've heard about this kind of Docker technology, and we think maybe we can use Docker to kind of make this a bit easier to share this image. So what would you need to do to take our sample application and wrap it up with Docker? Well, what you actually need to do is create what they call a Docker file, which you can see here. And a Docker file is kind of like the recipe that tells the Docker engine how to build your application into a Docker image that you can run containers from. It's just a really, really simple text file that you can it's a text file that you can run, and Docker knows how to interpret, and that will create your lightweight binary image that we can run your kind of applications from. So I'll just quickly explain the kind of the different lines. So we start up with what they call the from tag, and what this allows you to do is specify an existing Docker image that exists on the internet on your local repository to build your application from, because I don't want to start from like a completely raw Linux instance, right, and then have to install node and npm. I can use a URL for a Docker image that already exists on the internet in a kind of remote repository, and then we can build our image based on that. So this is going to be a Linux image with a node and npm already installed, so I don't have to kind of manually configure that. It's much quicker to get started. Then I'm going to copy. I'm going to copy my code from my local directory into the Docker image. I'm going to say I've got some local code. I want you to kind of bake this into the image. I'm going to run the npm install command, which is what I did to install my modules. I don't want to do this when the application starts. I want to have this already done and kind of baked into the app. And then we kind of define some kind of configuration parameters to make it the app know that it's running in a Docker container and what port it wants to talk to. And then finally, we have this thing called command down here. And what command does is just say, this is the kind of application, the command that I want you to execute when the container starts, so that you know that it's up and running and everything's working perfectly. Again, I've already got the Docker command line installed, right? So I have this command Docker, and there's all the kind of commands you can talk to. But once you've defined your Docker file, you just need to type the command docker build. And you can give it a tag, so we're going to call it Blue Chatter Latest, and then again that's around versioning, right? I can give it lots of different tags, so I can swap between different versions. I'm going to use the Docker. I'm going to use the Docker thing from my local registry. Let's see. Oh, that's worked. Okay. So what it's doing now, Docker's running through all of those kind of commands in the kind of Docker file. It's going to build this into our lightweight binary image. That we can then start to run containers from, and then sort of like 10 or 20 seconds it will be finished, and you'll be able to see that in our kind of local image repository, and then we could really easily share this. So I'm not going to have to let my colleague go through the pain of installing Node and npm and Redis. I'm just going to be able to give him my Docker image, and then he'll be able to run it, provided he's got some kind of Linux instance running locally and he's got the Docker software installed. So it'll be much quicker. So this is a convenient break for me to have a kind of gulp of water while npm finishes downloading all those packages on the Wi-Fi. Come on, npm. So a quick thing to point out is you might be thinking, so I've talked about that Docker runs on Linux, and that's the way that you kind of get it up and running. But I've clearly got a Mac here at the front. So how is this working? The kind of standard approach, if you're using a Mac for development and you want to use Docker, at the moment at least, is to use the install Docker. It installs a Linux VM using VirtualBox or kind of other providers, and then the Docker command line will talk to your kind of local Docker instance running in a VM. So that's the way, if you're going to use kind of Mac for development, how you can kind of get everything up and running. Okay. So it's being a little bit slow. So what I will do, I wonder how long that's going to take. We'll give it another 10, 20 seconds. It's not finished. I can swap to the backup and kind of show you it kind of running locally instead. Too many packages. Okay, let me swap to... So it's going to be a race now to see which one finishes first. Right, let me start my backup VM, and I can swap over to that where I've got my kind of local image up and running. Okay, right, so just as it kind of finished in the backup, it's already finished. So sounds like it's done, so I can type Docker images. Now we can see that we have this image called Blue Chatter. It says it's built in, that contains all of my kind of application code. So now if I want to run my application as the image, I can type the command docker run, and we'll make it interactive so I can cancel it. and we type blue chatter latest to specify the version, and it's going to start up my application as a Docker container. But what's going to happen, right? Well, what happened is exactly what happened before. We don't have Redis available to it, right? Because we didn't define that in the Docker file. And again, this is running on a kind of its own virtualized, isolated environment. It's not got access to Redis running on my local host. So now we have to think about how do you put Redis in that environment. Now, one way would be to go and modify my Docker file and to work out the commands to kind of install Redis and build that into the image. But the kind of best practice with kind of working with Docker is that rather than having some kind of mega image, right, and treating it a bit like a VM, you actually break your application out into different component services, run them as different images, different containers that can kind of be scaled and kind of moved on demand. So, okay, I want to put Redis in a Docker image and run it as a container. I could start a new project and then go and kind of configure a new Docker file and work out how to get Redis kind of up and installed, and and that would work, and work out how to link them together. But I said one of the good things about using Docker is that there's a huge community around it, and people have already done a lot of the hard work for you, and I can use Docker Hub to pull Redis down. So if I go to the internet and I go to Docker Hub and I search for Redis, you can see, so there's 2,500 repositories that people have built versions of Redis with different configuration and put it and made it externally available to you. And you can actually see that there's a repo for the actual official Redis projects. They've kind of pushed that up there. So now, rather than having to do this myself, I can type the command docker pull Redis. And what it'll do is it'll go to the Docker Hub and pull that image down, then I'll be able to kind of start it up and hopefully get this running locally and kind of get it up and running. Now, again, I'm not going to wait for the internet. I've actually already done this. So you might have noticed before, I have a Redis image running locally, so it's just the one that I pulled down from the kind of external Docker repository. So I can type docker run Redis. And you can see now I've got my own Redis instance running in a Docker container. I didn't have to do anything, and it kind of looks the same as if I'm kind of running it locally. Okay, so we've solved two problems, right? We've got our Redis instance running in a container, and we've got our application running in a container. I want to be able to run them together and link them so they know how to talk to each other. And the way we do this is with a tool called Docker Compose. And what Docker Compose allows you to do is define what they call multi-container applications. So say I want a container for this and this and this, and I want you to link them together and set up the networking so they know how to talk to each other. And to use this, again, there's a little text file called dockercompose.yaml. YAML is just a kind of simple configuration script. If I go down to the bottom, it allows you to kind of define the containers that you want to run for your application. So you can see here, I'm saying I want a container called web, which is going to contain my local directory with all the source code in. I'm going to expose the ports I want to talk to it on. I'm going to link this to my Redis container. So what that means is it's going to set up the networking in the etc host file so that the Redis host name automatically resolves to the IP address of my Redis container, and it will manage the ability for them to kind of talk to each other. And then I want a second container in my app, which is Redis, and I'm going to use the image that I pulled from Docker Hub. So once you've defined that, if I want to spin up my entire app, I type Docker Compose up, and it should go and kind of pull everything down. And it's going to run through the commands to build that up again. So I'm not going to wait for that to finish because it's going to take too long. But what you would have seen then, if the internet was behaving a little bit, it would have spun both my containers up and kind of linked them together, and they could talk to each other. And now I could have accessed my kind of the external host with my application in, and that I've built into a container, and they're kind of linked together. So we can actually move that container over to our colleague now and get them to kind of to run it locally. So we've started to solve this issue of inconsistent environments. And let me jump back to my slides real quickly and then mirror the displays. There you go. Yeah, okay, that's working. So, we looked at how to kind of spin up your application with Redis, and I looked at how to use the technology called Docker Compose, which in theory should have started our application, but internet is being a bit slow at the moment. So in theory, we can now move the image that I built locally and push that to our colleague. We've solved this challenge of having inconsistent environments, right? So what's the kind of next step? Well, I think the kind of logical next step is to move to the cloud, because we've done the hard work of building our image into a container. Now we can just move it to a public cloud provider and get them to run it as a kind of scalable production system without doing any hard work, right? I can take advantages of elastic scalability, provisioning automatically based on load. I can cut down my costs, because it's much cheaper sometimes to use public cloud infrastructure, and I don't have to worry about any of the kind of operation side of it. Now, if you want to move your Docker image from kind of running locally to running in the cloud, there's a couple of things that you need to do, right? You need to be able to build your image and push that from running locally in your registry to the kind of remote third party. You also need to think about how you're going to access your application services, right? You could push Redis, that image, up into the cloud and kind of talk to it that way, or you could use the cloud-based application services and kind of implement those in your app. And then finally, you're going to start your containers from your images, right? How much kind of memory and CPU and all this stuff do you kind of want to do that? So let's look at doing this now. We're going to use kind of IBM's cloud platform called Bluemix to do this. Now, as the kind of internet is messing around a bit, I'm going to start the video for this part so we don't have to see me sweating a little bit. If I go read dev days, I'll go to mirror again. Scale. Yeah, that's better. Okay. So let me make this full screen. Okay, perfect. I'll go off there. So this is IBM's kind of Bluemix cloud platform, right? And it gives you a couple of different ways to run your code in the cloud, right? You can run as a platform as a service offering based on Cloud Foundry, which is a big open source project. You can use VMs, but what we're interested in is what they call IBM containers down there, right? It allows you to push your code directly into the platform, and then you don't have to worry about kind of setting up any environments. So if you go in, you can sign up for an account. It's kind of free for 30 days, and you can kind of get started and try out everything I'm showing you in the demo. But what you actually see here is when you go in, there's ability to start containers based on images, and you get a number of kind of pre-built images for you for popular runtimes like Liberty and Node.js and other kind of things. But what you're actually looking at here is your own private registry. So all the images in here are images that you can download and start to use, and we actually use one to build my application locally. Or you can put your own code in there. You can put your own images, the ones in purple. And we're gonna do that in the demo very shortly. So we're gonna put our own images in there, and when you've done that, then you can start kind of containers based on that. You can configure things like how much memory and CPU you want. You can add auto recovery and kind of take advantage of the cloud provider doing all that kind of hard work for you. But obviously, the kind of default images in there right now are the kind of raw ones for Node and Liberty, right? And we're not going to use any of those because they don't contain our application source code. So we need to work about a way to get our code into the platform. And there's kind of two ways you can do this, or there's two ways you can interact with the platform. You can configure Docker to talk, when I'm typing those commands with Docker CLI, to talk to the remote IBM Bluemix platform, right? So you're running Docker images and Docker run. It will actually be running it on the kind of remote cloud provider. But I actually like to keep my Docker CLI talking to my local Docker host. So there's a third party. There's a plugin for the IBM container system that handles things like authentication and all those things that you can install and get going really easily. So if you go into the docs, you'll see there's information about how to set up this IBM containers command line, and we're going to actually use that to push our code into the platform and to build it and kind of do things like that. So yeah, you can configure Docker locally to talk to the remote system. I prefer to have it kind of still working on my local development environment, and we're going to install the IBM containers plugin to be able to kind of get up and running really, really easily, and it kind of works on all different platforms. So I've already got this running on my command line. So anytime I type the command CFIC, and now I'm talking to the remote Docker host rather than my local environment. And what it actually does, it just wraps the local Docker command line, but it handles everything like authentication and the certificates and all that kind of stuff to do so in a kind of secure manner. So you can see if I type Docker images locally, right? This is my images in my repository running on my local system, but I can type the same command, CFIC images, running on the kind of remote system, and that will show me everything that's in that private registry. So generally, you're using the same commands as you did locally with Docker, but you're just using the kind of the remote system CFIC. So you can see we've got this local image blue chatter, right? And we're going to want to push this into our remote repository. And the way you do this with Docker is use the docker tag command, and you create a tag or a version of your image with the external repository and your kind of username, and then you can use the docker push command to push that image into the cloud. So you can see, okay, I've got a blue chatter image, so we're going to create a version of that or a tag. We're going to use the registry name for Bluemix's public cloud provider, so registry.ng.bluemix.net. I give my username of jthomas, so I've already kind of signed up and registered that. I'm going to create a version on the cloud, right? I'm going to call it Blue Chatter. I'm going to call it Blue Chatter Latest. And then if I run Docker images again, you can see that now I have two versions of the same image, basically. And we can now use what's called the Docker push command to move this into our private registry, and then we can start images working on the cloud based on that. So I'll just kind of authenticate with the cloud platform, and it will go and pull down my certificate so that I can kind of securely over SSL access my remote Docker host. And it's going to authenticate and pull down the certs. So that's working. So now I can look, and so these are the images in my remote repository, right? These are the ones that you saw in the kind of the web UI for the kind of the raw boilerplate runtimes. And you can also do things like, check out what kind of process is running and look at logs and all that kind of good stuff. So now we're going to type docker push, and that's going to take our kind of local image and kind of move it over to the cloud, and then we'll be able to kind of start some containers based on that and kind of scale up automatically. And I haven't had to do anything to my local image to make it run on the cloud, right? I'm able to use Docker and this technology to kind of abstract away all of the difficulties of managing cloud-based infrastructure. So I'm about to type the command docker push, and it's going to push my registry up to the cloud. So it's going to go and do that, right? So it'll push your image up, and it'll kind of push all your application layers and make them available in your kind of private repository, and you can start containers. Now that's one way to get your image into the cloud. The other kind of thing that you can do is get the cloud provider to build your image automatically for you. But locally, we use what's called the docker build command to build your image and put it in your repository. And actually, you can use the IBM containers command line with the same command, CFIC build. And what that does is it takes your Docker file, and it takes any kind of local source code reference, and it pushes it over to the cloud. So actually, the Docker build engine will be running on the remote cloud provider. And what this means is if you have a particularly big Docker image, it can sometimes take a while to kind of push it into the cloud, and it can be much, much quicker to use the remote build system to build your image automatically for you. So I'm going to show you that in just a second, right? So we have our kind of local image, and if we wanted to build that, we use docker build. And in this case, we're going to use the command CFIC build to do that remotely, and it can be much, much quicker because I only have to send up to the cloud my Docker file and my kind of any references to local source code, and I don't actually have to worry about kind of moving the entire image over. So let's see, there we go. So CFIC build. So, again, it's just using the exact same command as we did locally. So the commands are the same between the remote command line and the local one. And this time it's going to push my Docker file up. And you see the logs, right? This is what we would expect if we were kind of running Docker locally. But all of this build output is coming from the build system running in the cloud. And again, it can be much quicker sometimes depending on your kind of application size and what you're bundling in to use that. So they're the two ways that we can get our images from local environment into any cloud provider. We can push it, we can build it locally and push, or we can actually just simply build it using the cloud provider, and then they'll be available in our kind of remote repository, and we can start containers based of the results of that. So again, I'm gonna, in the video, I leave this one running and I swap back to the one we've just done because that's now finished. And if I type the command CFIC images or look at my repository, hopefully we should see that my version's there. So now you can see that you've got our Blue Chatter app that's running there, and we've got a tag. You can see I already had a backup tag in the background as well. So we've pushed that app that I had running on my local laptop into the cloud, and now we can go and start instances of my container based on that. So again, I could use the Docker run command line to do this, or CFIC run, but I think it's a bit more intuitive to use the kind of web UI to do this and not have to kind of spend time kind of messing around. So if you go into the Bluemix UI, you can see that I have the Blue Chatter image in my private repository. And then I can start to come in and I can start containers based off the kind of result of that. So I could go in and say, start containers and kind of get an instance of what kind of containers I can start. And I could go in and kind of fill in all the details about kind of memory size and get it up and running without managing infrastructure. And I can see how I can change the tag, I can swap to different versions. But if I was to do this, right, so go and fill in all those details and kind of start it up, right, we'd have the same problem that we did when I was running Docker locally, that we don't have a kind of Redis instance, right? I need Redis. I need to be able to talk to Redis. It needs to be able to talk to some kind of Redis service. And when we were running locally, right, we worked out a way to pull Redis down from Docker Hub and run that up and kind of connect them together. But actually, I'm using the cloud, and I said, the great thing about kind of working as the cloud is using kind of cloud-based services. So actually, rather than kind of manage this myself, I want the cloud provider to do this. And so I can provision through the catalog a Redis service and then get the cloud provider to kind of connect it to my app, and then I can talk to it and just use it, right, as a application service. I don't need to worry about kind of managing a kind of Redis service in production. So that's what we're going to do. We're going to use the Bluemix cloud provider to do this. So if I go to the kind of application catalog, this gives you all of the hundreds of different services that you can use for doing stuff. And I can search and say, okay, I want Redis. And I can see I've got 2 different providers. And I can click through. And then what will happen is I can then provision myself an account with this provider. And you get the credentials passed into your app as an environment variable. So all your app has to do is read those credentials from the environment variable, get the Redis client library, connect to it, and then I can start to kind of work with my application. And you can change things like, the great thing about cloud is I can change the plan or how much memory it has, and I don't need to worry about kind of doing that myself. So I've actually already provisioned this in the application, so I can go and start my container now and connect it to Redis, and it sure should work, hopefully, kind of really, really easily. So I'll go back to the dashboard, and we'll start our Blue Chatter app as 2 containers and bind our Redis service. So there we go. So I'll fill out the details, right? Put in what kind of container name you want. And I can see what kind of size. We can bind a public IP address because we need to be able to kind of talk to it. Rest and bind a public IP. I'll give it a port that I want to expose so that we can access our web application. You can bind things like persistent volumes if you need extra file storage. And now I'm going to add my Redis service, right? So all of these application services that I've provisioned to build my applications with. And as I said, what happens is the system creates the environment variables under VCAP services with those credentials, so that my application just has to read those and plug them into the client library. I don't have to worry about managing my kind of production Redis system. So it's going to kind of start up my application, the Blue Chatter app, running on the cloud. And we can go into the logs locally and kind of check that's working and check everything has worked. So if I go back to command line and type CFIC process, it should show you that we have a new container, the top one, which has just been started 21 seconds ago, which says that it is running. And now I can hopefully look at the logs for it. There we go. Seems like it's working. It's got networking. So we'll have a look in the logs and kind of check that everything is up and working. It's kind of working as expected. So there you go, right? It seems to have worked, right? So they're the kind of logs that we had running locally. It says it's connected to Redis. It's detected it's running on kind of in a Docker container on IBM Bluemix. That should be it, right? It should be up and running. So if I go back to my command line, I can go to my IP address. I can see that, look, there is the same container running on a public IP, but now it's running on a public cloud provider. And I have able to go in and type, hello, and open a couple of different tabs and verify that everything's working. But what we haven't had to do, we haven't had to modify our Docker images at all, right? I was able to just push that into the remote cloud provider and get it running really, really easily. So it was an easy way for us to get running with kind of public cloud infrastructure. Now, the next thing you kind of might want to do once that's finished is think about how you handle scalability, right? The ability to scale automatically based on user load, right? To add more infrastructure when, more containers when it gets busy and take them away, because that's one of the big advantages of running on cloud is that elastic scalability. So what you can do is start what they call a container group, which will actually start multiple containers for your application. And obviously you need to think about how you have designed your app, so it needs to be stateless and kind of designed to be scaled horizontally. And then we can get the platform to just start container groups, which is multiple containers for an app, and then the platform will bind an external URL to it and then load balance all the different requests between that are coming in to your application and automatically manage things like scaling. So I'm going to show you quickly in the last couple of minutes how to start a container group. So again, we can go back to our kind of private repository, and we start our Blue Chatter app, and this time we want to bind a URL and have the platform kind of handle load balancing. So let me skip along a little bit. So this time you can see I've actually gone to the kind of scalable group tab. I can say how many instances I want, right? Let's start with 2 instances. And again, you can define the kind of infrastructure you want to back that. I can do things like, again, I'm going to expose a HTTP port, and I'm actually going to enable auto recovery. So this is if any containers die, I want the platform to automatically restart them and kind of manage that side of it. So I don't have to worry about this whole running Docker in production thing. And again, it's the same kind of mechanism, right? We're going to use the cloud-based services to talk to Redis. So I'm going to go down and bind my application services in advanced options, and it's going to be talking to the same Redis service as my kind of single container did, but this time we were running kind of multiple container applications automatically. So again, it clicks create, so the platform's going to go and kind of spin up those different containers. So if we drop back to the command line, we'll be able to see hopefully that 2 new containers have been started and check the logs and make sure everything's kind of up and running. So it looks like that has worked. I can just slowly. So if I have dropped back to the command line, you can see now actually I've got 2 new instances of my container that have been spun up by the platform. It says that they're running and they were started sort of 13 or 14 seconds ago. And if I check the logs for each of those containers, you'll say that, okay, that looks like it has worked, right? I see the kind of same output as we saw before. And then with this one, it looks like that has also worked. So if I go back to my dashboard, I should be able to click on the external URL. And then hopefully that will kind of show us our application running. But this time as what they call a container group. As multi-containers, the platform doing the load balancing automatically. So I can click over to my Blue Chatter group. Skip back. So there's the kind of dashboard, and I can click the external URL, and there we go, right? It's the same application that we had running locally, and then we ran as a single container. Now is being run as a kind of really useful kind of scalable container instance, but done automatically by the platform. I haven't had to manage that myself, haven't had to change that image at all, and you can see that that's working. So let me swap back to my slides, and then we'll just kind of wrap up. So let's quickly kind of recap what we ran through in the past kind of 45 minutes, right? We had a kind of local application that I was kind of working on in my development organization called Blue Chatter. And what we found is that to be able to share this with colleagues, there was a lot of different steps, right? I had to have Node and NPM and Redis installed in the same versions, and it wasn't really scaling, it wasn't really helping us get to this idea of kind of having a continuous deployment and deploying 20 or 30 times every single day. And we found ourselves constantly battling deployment issues. So we heard about this technology called Docker, which as long as we have a Linux system and we've got Docker installed, we can use to build these kind of lightweight application images and then share them with our colleagues and push them to the cloud. So we defined a Docker file, right, which is that kind of line-by-line instructions of the kind of recipe of how to build your application up into a Docker image. And then we did that locally, so we built our kind of local image. And we ran this locally with Docker using Linux. And we kind of removed the possibility of any of these works on my machine issues, right? Because once you've built it locally, you don't have to worry about setting up the environment anywhere else. And then the final thing is we kind of scaled it up, right? So we took our image and we moved it to a public cloud provider because we didn't have to worry about setting up lots of environments and configuring Linux VMs. We could just give them the Docker image, get them to run it in production and manage all that kind of hard but boring stuff that comes with kind of scalable production systems. And we're also able to take advantage of cloud services like Redis and connect them to our app rather than having to manage those ourselves and kind of concentrate on the code. So, if you constantly find yourself at work battling what they call, deployment issues, right? You're constantly hearing this phrase from your colleagues of, oh, it works for me. I checked in the code. There wasn't a problem. I don't know why kind of staging or production's broken. I kind of encourage you to think about using Docker as a mechanism to kind of get around this because it allows you to build your application into these lightweight images that you can run. And when they're executed, you're guaranteed to work in the same way as it did during development. So hopefully you start to kind of incorporate Docker. Rather than hearing the phrase, it works for me, you'll actually know when you say this, it means that it works everywhere because Docker is going to provide you with that mechanism. So thank you all for kind of listening. If you've got some questions, I think we've got about 10 minutes now before you have to drop off for another talk, or I'll be around for the rest of the day so you can come and say hello. So thank you.
Yeah, I have a question. What is the Docker's approach to managing databases? Where exactly the data go? Inside the image somehow, or it should be stored somehow outside the image?
So you're absolutely right. Docker's approach is that you attach what they call persistent volume. So you can attach external file storage to it that acts as that, because you can start your container, you can stop it, and you can get rid of them. How do you manage the kind of the state of the application? And Docker has the ability to, as I said, attach what they call persistent volume, which is like a persistent file storage to multiple containers. They can all talk to the same file system and give you that. Again, if you're kind of running on the cloud, what most people do is use one of those cloud-based databases and connect that to their container so you don't have to manage it yourself. And that means you can then spin up multiple instances and not worry about like the state between them. But to do that, you have to think about the architecture of your app and make sure it's a kind of stateless and it's designed to be horizontally scaled, right? It's not going to work if you have these big kind of vertical scaling apps which expect just more memory in instance.
Okay, thanks.
Welcome to you guys.
So I have a question. We see how it works with one application. Yes, but if we have an example like a network of microservices, so how IBM Bluemix, this technology, will handle the deployment, how with help of the thing we can manage the versions of all these stuff. So they will be deployed and nothing will be destroyed.
So how would you handle deploying like multiple microservices into production concurrent at a time? That's a challenge, right, for all companies. I think one of the things they can often do is you can deploy what they call some people call it like blue-green deployments or zero downtime deployments, where rather than like taking your app down and then spinning up a new one, you'll spin up the new version concurrently and use the platform routing to move some traffic across to it and check everything's working and have kind of automated system tests. And then if they call it like a canary build or something like that, if that works, then you can slowly move more of the traffic over. So rather than, used to like you have a server, right? And we'd have one server, and so we'd have to like take the app server down and then put the new code on and bring it up. Now you can just deploy the new version of your app concurrently and use the load balancing and routing capabilities of the platform to move a little bit of traffic across and then check, okay, is everything working? Is anyone complaining? No, and we can slowly move across. So I think that's what most people do. Something else you kind of mentioned, which I think is important, is okay, how do they all communicate, right? It's easy when you're like got Redis and a web server, but if you've got multiple microservices, how do they discover each other? And so most people, to kind of solve that issue, use a service registry. Something like Eureka is a popular one from Apache, where instances, microservices can register themselves in the service registry when they're up and available, and then other apps can use that to query it. So that's, I think when you go from running a simple application like that to running dozens of microservices, it does get more difficult to coordinate and the things and that's what I think that's the advantage of using a cloud provider, I guess, over doing it yourself, is that they generally try and cater for that stuff and make it easy to use, because those are the hard things, right? Running Docker locally on a laptop and be like, oh, look how easy it is, but to move that into a production system, there's lots of kind of challenges around coordination and kind of zero downtime deployments, and I think that's where the provider should help you with manage that kind of stuff. Yeah, I think there's some more questions down here.
Hi. I noticed on Bluemix web interface deploy with caution vulnerability check.
Yeah.
How is it being done on your personal images, or
so when you push your image into the cloud, I push it in, or I build it and push, the system will using some very clever research stuff that it will automatically scan your images constantly and look at the base image you depend on and any kind of libraries and things you pull in, and based on its knowledge of security vulnerabilities coming out, can tell you when the base image you built off your version of Ubuntu needs to be upgraded because there's an SSL cert and that kind of stuff. So I don't know the exact details about how the mechanics of it works, but yeah, I think it's a really, really neat feature, because I think one of the problems that people have found with using Docker is you build your image and you're like, okay, that's great, I'm done, and upgrades to Docker images is a bit of a kind of fuzzy, what do you do about security patches, right? And people have kind of just ignored that. So I think often with Docker, people don't think about that side of it, and I think that's a really great feature of IBM's cloud platform, is that we can help you to manage that, because it's a real thing. People build their images, they'll run it, but because it's not a VM, they don't really think about how you do updates to software, and it's 12 months down the line. And so, yeah, I think that's a really good feature of the platform. And I don't know what other the cloud providers have, but yeah.
I have a question about networking.
Yeah.
So basically, they all use the host's network. If I run locally many applications,
that's right.
Then so each would run on own port, but the same IP address.
Yeah. So if you're running Docker Compose locally, there's ways to dynamically set the port for each instance so it's slightly different. But yeah, because if I try to spin up multiple containers for my web app, right, and they're all trying to bind to the same port, it just doesn't, one of them wins, the rest lose. So there's a couple of ways with Docker Compose to manage that. But yeah, there's a couple of different options to manage that. Yeah, but it's a good spot basically. But then, that's running locally. If you kind of run in the cloud, you're much likely to either use the environment variable based approach or with a service registry to handle the kind of discovery and that kind of stuff. So, any more questions? Okay, all right. Thank you, everyone. I'll be around all day and be on the IBM stand. So if you want to come and talk to me and have a chat about anything cloud based, then that's great. Thank you.